All right. Our presenter tonight is Paul Morow, and Paul is a graduate of Purdue University with a BS in chemistry. He's currently a scientist at XLEAD, a subsidiary of Germany's Merck. He has a lifelong interest in astronomy. He has attended Astrofest and NIAG for just about as long as they were put on, and has been to many other star parties over the many years that we used to be going. It was always a lot of fun. He was also the editor of the Calumet Astronomy's newsletter, the Cass Mirror, from 96 to 99. He's currently a member of the Indiana Astronomical Society, and he has owned many telescopes, including a 25-inch obsession for deep sky exploration and various refractors of various sizes, from about 4 inches up to just over 7 inches for lunar, planetary, and solar observing. So, a very nice set of telescopes indeed. His current interests are lunar and planetary observing, his equipment and skills. Through his equipment and skills, he's become a very proficient planetary and lunar observer. And so tonight he's going to share some of that expertise with us. Paul, thanks for taking the time out of your busy schedule for tonight. So please tell us all about lunar observing. Thank you.
Yeah, thanks, Joe, for the nice introduction. And I'll share my screen here. Okie doke. Yeah, I've been observing for over 40 years easily. And my main instrument that I've owned for over 30 years is a 6-inch astrophysics that you could see in this picture, looking at the moon. And even from being a young boy, I was always fascinated with the moon. And so over the years, I've kind of become a lunatic and owned several books on the moon, and always enjoyed looking at the moon and sharing the moon with friends and neighbors. So why is Paul a lunatic? Well, there's the three main reasons. Is the moon is available from your backyard without driving to a dark site. So it's nice to be able to get out during the work week and have even 30, 40 minutes to relax and enjoy the moon and the changing landscape along the lunar terminator during the lunar phases. It's always changing. And even when you observe the moon during sunrise, and the sculpting of the light always changes with the craters. And then if you observe them again during sunset, the sculpting of the light is totally different. So it's really amazing to see the structures and the craters and different lunar features during the entire month. And so that's why I'm a lunatic. And tonight, I thought some of the major features to explore would be like the Luna Marina and the lunar craters and the mountains and the rays and the rilles and the domes. Those are some of my favorite things to observe on the moon. First, with the lunar seas, the dark regions are solidified lava flows from between 3 to 3 billion years ago, a billion years younger than the majority of the lunar surface. The Mare Tranquillities contain the Apollo 11's landing site, and the lunar seas are also fairly dark and less reflective of the sun's light than the light gray areas that surround them. It's not all great seas. If you look carefully, you can also spot some smaller lakes and marshes and bays that litter the lunar surface. The ocean Procellarum is the largest of the lunar marina, and it's one designated ocean. It covers approximately 4 million square kilometers, and it contained Apollo's 12 landing site. Here I have a map showing all the oceans on the moon, and you can see the darker features here. And the moon shows these pot marks that we'll move on to craters, and the moon shows these pot marks and dents on its rocky surface, most of which have been formed by chunks of space rocks smashing into it. And due to no weather on the moon to wear these craters down, so they're there to stay, with some dating over 2 billion years old. Lunar craters come in a whole variety of brightness, sizes, and depths, with some boasting raised rims and central peaks. As the moon shifts through its lunar phases, you can watch the variation in lighting that alter their features, making them even more exciting to observe. Here I've got a map with some of the major, larger craters labeled where they're positioned on the moon. Here's the crater Clavius. It's toward the southern limb of the moon, and it causes it to appear oblong due to its foreshortening. Its great size makes it visible to the unaided eye as a prominent notch in the terminator about 1 to 2 days after the moon reaches first quarter. And the floor of Clavis forms a convex plane that is marked by many interesting crater impacts. The most notable of these is a curving chain of craters that begins with Rutherford in the south and arcs across the floor in a counterclockwise direction, forming a sequence of ever diminishing diameters.
Hmm.
And the crater Plato is a lava-filled lunar impact crater on the moon with a diameter of about 101 kilometers. And Plato is located on the northeastern shore of the Mare Imbrium and at the western extremity of the Mountain Alps mountain range. The flat floor of Plato has a relatively low albedo, making it appear dark in comparison to the surrounding rugged terrain. And the floor is free of significant impact craters and lacks a central peak. However, there are a few small craterlets scattered across its floor. And Copernicus is a lunar impact crater located in the eastern ocean of the Procellarum. And Copernicus is visible using even binoculars and is located slightly northwest of the center of the moon's Earth-facing hemisphere. The crater's rays spread as far as about 800 kilometers across the surrounding mare. The rays are much less distinct than the long linear rays extending from the crater Tycho. And we'll move on to the lunar mountains. And these mountain ranges can range anywhere from 31 to 491 miles. Despite their gigantic size, you really need a telescope to get a full benefit of spotting these incredible landmarks. The mountain ranges are best viewed while the moon is in a transitional phase with its terminator visible. The Apennines ranges are best viewed while the moon is transitional phase with its terminator visible, or the moon at its highest mountain range near the Mare Imbrium, extending over 400 kilometers. It contains the Mons Huygens and the moon's tallest mountain, Hadley, the Apennine Valley, where the Apollo 15 landed. And here I have a map showing some of the mountain ranges and Apollo landing sites. The Apennines Mountains, sorry, features obvious features, especially visible on a full moon, is the race. Let me see. I think I went forward. Yeah, sorry about that. I I can't get it to go backward. Oh, there it goes. Yeah, the Apennines Mountains are visible on the 8-day moon. And here's some photographs and where they're located on the moon there. And we'll move on to the lunar rays. One of the most obvious features is that, especially visible during the full moon, is the system of rays emanating from certain craters. The origin of the rays is generally ascribed as ejecta, material that was hurled out when particles of rock crashed into the lunar surface, forming the craters. The different types of rays, those of Tycho, are long and narrow, whereas of Copernicus are less well defined and wispy. Some believe the ray craters were created when the moon was only about 100 million years old. This was used to explain why only a few craters have rays, because they were formed when the crust was very young. The rays are widely interpreted as splash marks from very young craters. Here I have a table that lists craters known to have visible ray systems associated with them. Tycho, of course, is the most famous because its rays are very bright. Yes, and here's a photograph of the Tycho. It's one of the most brightest craters with a diameter of about 85 kilometers and a depth of 4,700 meters. And the crater's sharply defined, and unlike older craters that have been degraded by subsequent impacts, the interior has an albedo that is prominent when the sun is overhead. And the crater is surrounded by a distinctive ray system forming long spokes that reach as long as 1,500 kilometers. And we'll move on to the lunar rilles. There are three types of rilles found on the lunar surface. The sinus rilles that meander in a curved path like a mature river and are commonly thought to be remains of a collapsed lava tubes and extinct lava flows. And there's also the acuate rilles that have a smooth curve and are found on the edges of the dark Luna Marina. They are believed to be formed when the lava flows that created the mare cooled and contracted and sank. And these are found all over the moon. And then there's straight rilles that follow along linear paths and are believed to be Garabin sections of the crust that have sunk into two parallel faults. And these can be readily identified when they pass through craters and mountain ranges. The Vallis Appice is by far the largest Gapen rill, and indeed it's regarded as too large to be called a rill, and it's bisected by a linear rill, the Rima Ardrius, and of the West Mare Tranquillities is a clear example. The Scooter or Schroeder's Valley, frequently known as the Vallis Schroeteri, is a sinus valley or rill on the surface of the near side of the moon. This is the largest sinus rill on the moon, and it begins at 6 kilometers in diameter at the crater located about 25 kilometers north of Heratius. And the start of the rill is termed the Cobra's Head by some observers due to its resemblance to a snake. The rill has a maximum width of about 10 kilometers, then gradually narrows to less than a kilometer near its terminus. The best example of an acute rill is the Rima Surplus Gallus in the southwestern Mare Serenities. The acute rills are curved formations like parentheses or a bow, and these depressions are formed along the edges of the marina within some basins. Acute rills are likely formed as these faults sagged under their own weight toward the center of the basin, causing the edges to pull apart, and the rill shape follows a circular shape of the basin. And then straight rills, which are thought to have formed due to tectonic forces. These valleys are which form when the surface pulls apart under extensional stresses and a block of crust drops down to create the valley floor. The largest rill on the moon is a straight rill known as Rima Soralis. It extends about 400 kilometers across the lunar near side of the Oceanus Procellarium. On a good night, when the moon is waning and the photography results in large shadows being cast, you may be able to find it with your telescope. The last feature is lunar domes, which are some of my favorite things to observe on the moon. The lunar dome is a type of a shield volcano that is found on the surface of the moon. They are typically formed by highly viscous, possibly silica-rich lava erupting from localized vents, followed by relatively slow cooling. The lunar domes are wide, round, circular features with a gentle slope rising in elevation a few hundred meters to a midpoint. They are typically 8 to 12 kilometers in diameter, but can be up to 20 kilometers across. And some of the domes contain a small craterlet at the peak. The cluster of lunar domes on the Marius Hills is considered as a possible landing site for Apollo 15. There are concentrations of lunar domes near the craters Rilles. And here I show a map with many of the locations of a dozen key domes and dome fields that are within reach of amateur telescopes. There are large concentrations of lunar domes near Copernicus on the 10 to 11 day moon. These are some of my favorite dome fields that I try to explore whenever it's clear on the 10th to 11th day moon. And there are several lunar domes near the crater Rilles on the 10-day moon. The Kai's Pi is simple to find due to the Keys crater near Mar Needham and the 9 to 10-day moon. This dome is about 6 miles wide and is topped by a summit caldera, and it's visible in excellent seeing in a modest telescope using high power. Burt is easy to find thanks to its proximity to the famous Straight Wall, the lunar fault. If you follow Burt Rill north, there's 2 small domes, each bisected by the narrow rill, and this can be seen on the 8-day moon. And again, it's best to use high magnification on this one. And again, the lighting really makes a difference. Some of these lunar domes, if you're a day late, the light will wash it out and you can't really see them. So the lighting of the right day makes a big difference. The Arrigo domes, the alpha and beta, are both more rugged than most of with textured surfaces, best seen in low slanted sunlight on the 6-day moon. And both domes are about 980 feet high. Yeah, to the right of the crater Milchinus, and to the left of Michielis A crater, the volcanic dome known as Michielis Pi sits between 2 craters on the 10-day moon. The dome is very gentle, though it is about 10 kilometers in diameter. It only rises about 230 meters above the surrounding plain. There are a number of smaller domes in the surrounding region, and they are a nice challenge as they are only visible near local sunrise and sunset. Accessories to improve your lunar observing. I've found over the years a clock drive with an equatorial mount is best, especially when you use very high powers above like 300, 400 power. When the seeing is good, it's best to have a clock drive and you're able to relax and observe a moving target without pushing the telescope to chase the view. And also binocular viewers permits viewing with both eyes and allows more comfortable viewing experience. And it reduces the problems of floaters, particles floating in one's eye, especially when using high magnifications and thus small exit pupils. And a comfortable and adjustable chair is always best when observing. In conclusion, observing the moon phases is a delightful and educational activity for all ages. And with the right tools and little planning and a sense of wonder, you'll find yourself captivated by the beauty and intricacies of our nearest celestial neighbor. As you become more familiar with the moon's features, you'll develop a deeper appreciation for its ever changing appearance in the night sky. I have a list for further reading if you want to learn more about the lunar surface and its features. And that's the end of my presentation. And if there are any questions, I'll try to answer them.
All right. Thank you, Paul. Appreciate that. Are there any questions for Paul?
Paul, do you do any photography?
Um, no. Years ago, like before I got married, I had more free time and I started dabbling photography a little bit, but I was kind of a perfectionist, so I was like never satisfied. Like I'd take some pictures and like family and friends would be impressed and think they're really nice, but I always felt that the images or photographs I couldn't capture like what I see in the eyepiece fully. So I always wanted to try to do it better. I felt wanted to do it better, but years ago when I was younger.
Is there an astronomy club down there in Carmel, or are you on your own?
Um, just the Indiana um, Astronomical Society. So, but I've observed with a few of the Indianapolis folks a few times, but I'm kind of more of a loner.
Paul, are there any special resources for the domes? If you'd like to kind of concentrate on domes, is there a particular book or other software
Um,
resource like the virtual moon that would help identify locations for the domes?
um, yeah, there's if you do just a Google search, there's a few. Sky and Telescope has a nice site that gives a list of some nice domes, and there's a one lunar book. I think I may have put it on the on my list, but it's a small. It's like a textbook. I think it was a college textbook for lunar domes, and it's it was an expensive book. It was about $70, and but it's got like a lot of real like physics and stuff and about domes and structures and things. But it has a few nice photographs, but it's that's really about the only book that's dedicated to domes that I was able to find, and that's why I bought it. So,
In one of a couple of the slides, you mentioned medium and high power. What is medium power? What is high power?
for the moon, I'd say medium power would be about 150, and the 200 maybe 250, and then high power is I'd say about 280 plus, about close to anything like 300 and over. I'd consider high power. Um, usually you need good seeing of course, for a 300 and over. But on a typical night, even the seeing is poor. Usually on the moon, you could at least do 200.
So that means it just becomes a matter of knowing where to look.
Yeah, yeah. And how the seeing is. And
The impact of aperture, do you see a great deal of difference in being able to find domes, for example, using 6 inch versus 4 inch?
yeah, I've several nights I like observing with two telescopes at the same time. And I usually set up like a 4 inch and a 6, or the 4 and a 7 inch. And I with lunar domes, um, you could really see like the domes twice as good in the
Mhm.
larger telescope than the 4 inch. And especially on nights that the lighting isn't quite right. And like, let's say you were looking for domes and you wanted to observe the 10-day moon, but it was cloudy. And so now you're looking at a 11-day moon and there's much more light and it's washing out like some of the domes. But with like a 6 inch, 7 inch refractor, they're still within reach, even though you're a day late. But with a like a 4 inch, you might only see half the domes because they're washed out. So
Yeah, just don't have the resolution.
yeah.
Yeah, I could see that. One of my favorite features are the shadows. You're seeing the shadows going through the crater peaks, and between the various features that are on there, and then if you watch long enough, you see the shadows change, and I love to see the relative animation of the moon because of that, and so
Mm-hmm.
that makes it I think very enjoyable during a session. We have two people within Fort Wayne Astronomy that have the Astronomical League's Lunar Observing Award. And so we've got some experience in the club. Billard Jeffkin was one of those, and Laura has a moon observing small group. And so people that want to find some experience in lunar observing, we have some locally. Just a matter of reaching out to the right people and asking your questions and getting some solid answers to get you going. So, are there any other questions for Paul?
Yes, Paul, this is Joseph Lawrence. I was
Mm-hmm.
wondering, do you have any preference for particular filters, colored filters, or other that help you pick out some of the details that you're interested in?
Um, yeah, years ago I like experimented with filters, and really the only filter I think for planetary, the colored filters do work on different planets, especially like Mars. Mars using red or orange filter, and sometimes even green, um, really helps, especially on a night of very poor seeing. And if the seeing is very poor, then I use colored filters on the planets, and it helps with the seeing and steadies the image. But on the moon itself, um, years ago, there was a lunar filter. They probably still make them, but I know like Orion used to sell them, and that's where I purchased mine. But it was years ago, back in like 1980s to early 90s when I purchased it, and I'd use it on the full moon, and sometimes that would enhance the contrast during a full moon to look at rays and different features. But typically now with the moon, I want all the light I can get, and especially when you use high power. Um, if you're able to use like 350 and 400 power on the moon, the images are really quite stunning. And so a filter would just make the image too dim. And so I don't use them on the moon.
The binocular viewer also helps with overcoming seeing. So you don't necessarily need filtering for that with the moon.
Yeah. Yeah, and I use a binocular viewer like about 90% of the time uh, now. Um, over like I think I purchased a binocular viewer about 8 to 10 years ago, and it really changes your observing to a whole other level, and especially it really helps to beat the seeing when the seeing is poor. And using two eyes, it really steadies the image. Um, Years ago, when I bought the binocular viewer, I have a my daughter was young at the time, and she'd seen Saturn several times in my telescopes, but never through a binocular viewer. And so I called her over to see Saturn, and she said, "Oh, Saturn is so clean when you use two eyes. The image is so clean." And so that's just from a young person's perspective of good seeing conditions when you're using both eyes with a binocular viewer. It really cleans up the image.
I have a quick question.
Sure.
Um, One of your early slides, you showed the Alpine Valley, and that's an area that I got interested in and started to photograph. I only tried it twice, but inside that valley is a long canyon. Well, I'll call it a canyon. I'm sure that's wrong. Have you had any luck resolving and seeing that canyon in the valley?
Yeah. Um, I've seen it maybe 3 or 4 times, and that's and like I've been observing the moon for over 40 years, so I've only seen it about 3 or 4 times, and the lighting has to be just right. So you've got to be it's the day or the night has to be just the sculpting of the light needs to be perfect, and the seeing needs to be good. So you need good seeing, and lighting has to be just right, and you just got to be really lucky. It has to be a good timing and a good night. So I've seen it about 3 or 4 times, and each time I've seen it, it's been in a telescope, at least about a 5.5 inch telescope to a 6 inch telescope. I've seen it. So about 140 millimeter telescope was the smallest I've seen it in.
Yeah, that's what I'm using here. And the last time I photographed it, I you can make it out, but kind of like I can relate to what you're saying about kind of being a perfectionist. The
Mm.
image that I took, you can see it, but I want to get it better and sharper and more defined. So I'm just going to make that a personal quest to try to capture a real nice picture of that. Is that technical? What is that? Is that a valley or a rile or what is that in?
Yeah, it's a valley down in there. It's like a deep canyon. It's a kind of a rill. I think in books they call it a rill, um, in the center of the valley.
Okay. Well, that's neat. I like I said, that's one of my favorite areas to go to, and hopefully one of these months I'll be able to show a better picture of it than what I've currently got.
Hmm.
For timing purposes, for planning purposes, to see what day you have to be with the moon, there is a moon simulator called a virtual moon that's available that will let you change dates, and it will show you where the terminator is going across, and give you a bit of a rundown on the craters that are along the terminator. So I've found it handy to use that in order to make sure that you're looking at the right time for the various features that you would be interested in. And it's downloadable off. I have to look up the website. Don't recall what it was. I ran across it reading something in Cloudy Nights about it, but it's called Virtual Moon. So for planning purposes, I think you'd find it handy. Anything else for Paul? If not, thank you very much, Paul. Appreciated the presentation, and had good discussion afterwards. So very good. Thank
Yeah,
you very
thank
much.
you.